Imagine pressing rewind on the entire universe. Galaxies contract, stars disappear, space shrinks, time itself begins moving toward its origin. Continue far enough, and every event in cosmic history vanishes into a single beginning. But then an unsettling question emerges. What lies on the other side of that beginning? What existed before the first moment? What was present before time, space, matter, energy, and every law of physics we know today? Modern science has brought us astonishingly close to the birth of the universe. Yet one mystery remains untouched. Tonight, we investigate the deepest question ever asked. What happened before anything could happen? Human beings have always been driven by a desire to understand why things happen. From the earliest civilizations to modern scientific laboratories, people have searched for causes behind the events they observe. When a tree falls, we ask what made it fall. When a storm appears, we ask what created the storm. When a star shines in the night sky, we ask what powers its light. Every answer naturally leads to another question, and every explanation seems to reveal a deeper layer waiting to be understood. This pattern has shaped the entire history of knowledge. For centuries, people looked at the movements of the planets and wondered what guided them across the heavens. Later, science revealed the role of gravity, yet gravity itself became another mystery. What causes gravity to exist? How does it work? Einstein provided a deeper explanation by describing gravity as the curvature of space-time. But even that remarkable insight did not end the chain of questions. Why does space-time exist? Why does it behave according to those laws? Why does the universe possess the structure that allows such phenomena to occur? The deeper we investigate reality, the more we encounter a fascinating pattern. Every explanation appears to rest upon another explanation. Every answer points toward another question hiding behind it. It is like exploring a series of rooms in an enormous building. Each time a door is opened, another corridor appears with more doors waiting ahead. The search for understanding continues, but the final room never seems to arrive. Modern science has achieved extraordinary success in explaining how the universe works. Astronomers have traced the evolution of galaxies across billions of years. Physicists have uncovered the particles and forces that shape matter. Cosmologists have reconstructed much of the universe's history back to an incredibly early stage, shortly after the Big Bang. Yet even these achievements eventually lead to a boundary where the same question appears once again. Why? Why does the universe exist at all? Why are there laws of physics rather than no laws? Why is there something instead of nothing? These questions are different from most scientific questions because they do not merely ask how something works. They ask why there is a reality capable of working in the first place. If we discover what caused a star to form, we can ask what caused the cloud that formed the star. If we discover what caused the cloud, we can ask what caused the earlier conditions that created it. The chain continues backward through cosmic history. Eventually, we arrive at the earliest moments of the universe itself, and then the question appears again. What caused that? Many people assume there must always be an earlier event. After all, every experience in everyday life seems to follow this pattern. A seed grows into a tree, a spark starts a fire, a falling object creates an impact, causes produce effects, and effects become causes for other events. Our minds are trained to think in this way because it reflects the world around us. Yet when we apply the same reasoning to the entire universe, something unusual happens. The chain of explanations stretches farther and farther into the past until it approaches a point where the concepts we rely upon begin to lose their clarity. The universe itself becomes part of the mystery. Space becomes part of the mystery. Time becomes part of the mystery. At that stage, the question is no longer about a specific object or event. It becomes a question about existence itself. Imagine reading a book and asking why a particular chapter exists. The answer may be found in the chapter before it, but eventually you reach the first chapter. At that point, asking what previous chapter caused it no longer works because there is no earlier chapter within the story. The question must be approached in a completely different way. The search for the first cause presents a similar challenge. Every explanation seems to lead backward towards something more fundamental. Yet sooner or later we reach a point where ordinary explanations may no longer be enough. The question that appears at the end of every explanation is not simply what happened before, it is whether there must always be a before at all. This is why the mystery of the first cause remains one of the deepest questions ever asked. It stands at the intersection of science, philosophy, and cosmology. It challenges our assumptions about beginnings, causality, and the nature of reality itself. Every attempt to explain existence eventually encounters it. Every journey backward through the chain of causes eventually arrives at the same destination. The question waiting at the end of every explanation is not merely what created the universe. The question is whether the universe requires the kind of explanation we have always assumed it needs, and that realization leads directly to the next mystery. If every explanation points toward an earlier cause, why does tracing reality backward never seem to reach a true beginning? The natural instinct of the human mind is to search for origins. Whenever we encounter something important, we want to know where it came from. We look at a river and wonder about its source. We see a mountain and ask how it formed. We examine a living creature and ask how it began. This habit of tracing things backward has helped humanity uncover countless truths about the world. By following chains of causes into the past, scientists have explained everything from the formation of planets to the evolution of life. It seems reasonable to assume that the universe should follow the same pattern. If galaxies exist today, they must have formed from earlier structures. Those structures must have emerged from even earlier conditions. If we continue tracing this sequence backward, it feels as though we should eventually arrive at the very first moment, the ultimate beginning from which everything else emerged. Yet something surprising happens when we attempt this journey. The farther we move into the past, the more difficult it becomes to identify a true starting point. Every answer appears to reveal another question hiding behind it. Every explanation seems connected to something that came before. Instead of reaching a final foundation, we find ourselves standing before another layer of mystery. Modern cosmology provides an excellent example of this process. Today, scientists can reconstruct much of the history of the universe. Observations show that galaxies are moving away from one another, revealing that space itself has been expanding for billions of years. By mentally reversing that expansion, researchers can trace the universe back to an earlier state when everything was far closer together. As the universe becomes younger in this reconstruction, temperatures rise dramatically, galaxies disappear, stars have not yet formed, even atoms cannot exist because conditions are too extreme. Continue farther backward, and matter itself becomes increasingly difficult to describe in familiar terms. Eventually, cosmologists reach a period so early that our current theories begin to lose their reliability. The equations that successfully describe the universe today no longer provide complete answers. Physics can approach this boundary, but it cannot yet cross it with confidence. This creates a fascinating situation. Science has become extraordinarily good at explaining what happened after the universe began expanding. Yet the closer we move toward the ultimate origin, the less certain our descriptions become. The chain of explanations remains impressive, but it never quite reaches a final beginning. The problem is not simply a lack of information. It may be connected to the structure of reality itself. Imagine standing between two mirrors facing one another. Each mirror reflects the image in the other, creating what appears to be an endless corridor stretching into the distance. No matter how far you look, another reflection appears beyond the last one. The sequence seems to continue indefinitely. The search for the beginning of reality can feel similar. Every time we identify a cause, another question emerges behind it. If the universe began with the Big Bang, what produced the conditions that allowed the Big Bang to occur? If a deeper process existed before that, what produced that process? The chain continues, and the final answer remains elusive. This difficulty has led philosophers and physicists to consider a possibility known as infinite regress. In an infinite regress, every event is explained by an earlier event, which is explained by an even earlier event, and so on without end. There is never a first link in the chain because the chain extends infinitely into the past. This idea seems to solve the problem. If there was never a beginning, then perhaps there is no need to explain one. Yet many thinkers find this conclusion unsatisfying. An endless chain of causes may explain how one event leads to another, but it does not necessarily explain why the chain exists at all. The deeper mystery remains untouched. Other researchers have suggested that the problem arises because we are applying ordinary concepts to an extraordinary question. In everyday life, every event occurs within time. Causes happen first, effects happen later. The sequence feels obvious because it matches our experience. The origin of the universe may not fit this pattern. If time itself emerged with the universe, then tracing reality backward eventually reaches the point where time no longer exists in the form we understand. At that stage, asking what happened earlier becomes difficult because the concept of earlier may no longer apply. A useful comparison comes from traveling north on Earth. As long as you remain below the North Pole, moving farther north is possible. Eventually, however, you arrive at the pole itself. At that point, asking what lies farther north loses its meaning because north is the direction that led you there in the first place. Some physicists believe the beginning of time may be similar. The universe could possess a boundary where the concept of before ceases to function. If so, tracing reality backward does not fail because the beginning is hidden. It fails because the question itself changes at the deepest level. This realization reveals why the search for origins remains so challenging. The closer we move toward the ultimate beginning, the more we encounter the limits of ordinary thinking. Concepts such as before, after, cause, and effect become increasingly difficult to apply. The framework we use to understand everyday events may not be sufficient for understanding the birth of the universe. What makes this mystery so fascinating is that it forces us to examine assumptions we rarely question. We assume every chain must have a first link. We assume every effect must have a prior cause. We assume time stretches backward indefinitely. Yet the origin of reality may require a completely different way of thinking. Tracing reality backward feels like following a road toward its starting point. The deeper we travel, however, the more the road itself begins to disappear. The path that seemed clear at first gradually fades into unfamiliar territory where ordinary explanations no longer provide reliable guidance. And this leads directly to an even deeper problem. If the origin of reality challenges our assumptions about beginnings, perhaps the difficulty is not merely finding what came first. Perhaps the hidden problem lies in the question itself, and in the way we imagine the relationship between cause, time, and existence. The question seems perfectly reasonable. If the universe began to exist, then what came before it? If there was a first moment, then what caused that moment? These questions feel natural because they follow the logic we use every day. Every event we observe appears to have a prior event behind it. Every effect seems connected to a cause. We are surrounded by sequences where one thing leads to another, so it feels almost impossible to imagine reality working any other way. Yet hidden within the question, what came first, is an assumption that may not be valid when discussing the origin of the universe. The assumption is that the concepts of before and after already existed. This idea is easy to overlook because time feels so familiar. We wake up in the morning, move through the day, and eventually reach the evening. Memories connect us to the past, while expectations point toward the future. Time appears to be the background against which everything happens. Because it is always present in our experience, we instinctively imagine it extending endlessly in both directions. However, modern cosmology presents a very different possibility. According to our current understanding, time may not be an eternal stage on which the universe appeared. Instead, time may be part of the universe itself. In other words, time may have emerged together with space, matter, energy, and the laws of physics during the earliest moments of cosmic history. If this is true, then asking what happened before the universe began becomes much more complicated. Imagine reading the first page of a novel and asking what chapter came before it. If the book truly begins on that page, then the question loses its ordinary meaning. The story starts there. There is no earlier chapter within the narrative itself. Looking for one means stepping outside the framework of the story. Many physicists believe the beginning of the universe may present a similar challenge. If time itself began with the universe, then asking what happened before that beginning may be like asking what lies north of the North Pole. The problem is not that the answer is hidden. The problem is that the question depends upon concepts that no longer apply. A useful way to understand this is through the relationship between cause and time. In everyday life, causes always occur before effects. A match is struck before a flame appears. A stone is dropped before it hits the ground. A seed is planted before a tree grows. Cause and effect depend upon temporal order. One event must happen first, and another must follow. Now imagine a situation where time itself does not yet exist. What would it mean to speak about a cause occurring before an effect? The entire framework begins to break down. Without time, there is no sequence. Without sequence, the ordinary concept of causality becomes difficult to define. This is why some physicists argue that searching for a cause before the beginning of time may involve applying a familiar idea in a context where it no longer works. The challenge becomes even more profound when we consider how deeply human thinking depends upon temporal language. Almost every explanation we create involves sequences. We ask what happened first, what happened next, and what happened afterward. Our minds naturally organize reality into chains of events, because that is how we experience the world. The origin of the universe may not belong to that category. It may represent a boundary where ordinary sequences stop being meaningful. This realization has led some researchers to suggest that the first cause may not be a cause in the conventional sense at all. Instead of being an event that occurred before the universe, it could be something more fundamental. It might belong to a deeper level of reality where our familiar distinctions between before and after do not exist. Consider a simple analogy. Imagine a circle. If you choose a point on the circle and begin traveling around it, every location has another location before it and another after it. Yet the circle itself does not possess a beginning or an ending. The concepts of first and last depend on where the observer starts. Some cosmological models suggest that reality may possess structures that challenge our ordinary understanding in similar ways. Time may not be a straight line stretching backward forever. It may emerge from conditions that do not themselves contain time in the form we recognize. Another hidden problem with the question, what came first, is that it assumes reality requires a first event. This assumption feels intuitive because chains of causes in everyday life usually have identifiable starting points. A building begins with construction. A journey begins with a departure. A conversation begins with the first word. The universe may not fit this pattern. Some theoretical models describe reality as something that does not require an initial event in the ordinary sense. Instead, the universe could emerge from deeper principles, quantum conditions, or structures where the distinction between beginning and continuation becomes blurred. This does not mean that the mystery disappears. It becomes even deeper. The question changes from what happened before the universe to what kind of reality could give rise to time itself. Instead of searching for an earlier event, we begin searching for a deeper framework capable of generating the conditions that make events possible. This shift is one of the most important developments in modern cosmology. It moves the discussion away from imagining a moment before the universe and toward understanding the foundations from which the universe emerged. The more scientists investigate the earliest stages of cosmic history, the more they encounter signs that the origin of reality may not resemble any event we have ever experienced. It may belong to a domain where ordinary intuition becomes unreliable and where concepts such as before, after, first, and next no longer provide accurate guidance. That is why the question, what came first, remains both powerful and problematic. It points toward the mystery of origins, yet it may also hide assumptions that prevent us from fully understanding the answer. The deeper we look, the more it appears that the origin of reality cannot be explained simply by finding an earlier event. Instead, it may require understanding a deeper transition where time, space, and existence itself first emerged from the unknown. And if that is true, then the next mystery becomes unavoidable. What exactly happened at the moment when the universe emerged from that unknown realm and the story of cosmic history began? When people imagine the beginning of the universe, they often picture a tremendous explosion occurring in an empty void. In this image, space already exists. Darkness stretches in every direction, and then suddenly a burst of energy erupts into that emptiness. While this picture is common, it does not accurately reflect what modern cosmology suggests. According to our current understanding, the beginning of the universe was not an explosion inside space, it was the beginning of space itself. The universe was not expanding into a larger, empty region. The expansion was creating the very framework within which distances, locations, and movement could exist. This distinction is important because it changes the way we think about the origin of reality. If space itself came into existence during the earliest moments of cosmic history, then there was no ordinary location where the universe began. There was no cosmic center surrounded by emptiness. Every region of space traces its history back to that primordial beginning. The event was not something that happened at a particular place. It was the emergence of the stage upon which all places would later exist. As scientists studied the expanding universe throughout the 20th century, they realized that the cosmos had once been far hotter, denser, and more compressed than it is today. Galaxies that are now separated by enormous distances were once much closer together. The farther researchers traced this process backward, the more extreme conditions became. Temperatures rose to unimaginable levels. Matter as we know it could not survive. Atoms had not yet formed. Even the particles making up ordinary matter existed in states very different from those observed today. Cosmologists reached a boundary where the equations describing the universe became increasingly difficult to apply. This boundary does not necessarily represent the absolute beginning of existence, but it marks the limit of what current theories can confidently describe. Beyond this frontier, our knowledge becomes uncertain. The familiar laws governing matter, energy, space, and time may no longer behave in the ways we expect. This is where the mystery deepens. Science has become remarkably successful at reconstructing the history of the universe after its earliest moments. Researchers can describe how matter formed, how stars ignited, how galaxies evolved, and how cosmic structures emerged over billions of years. Yet when we ask what happened at the very instant reality first appeared, the answers become far less certain. The reason is that the origin of the universe is unlike any event we observe today. Every event in ordinary life occurs within an existing framework of space and time. A star explodes somewhere, a planet forms somewhere, a particle interacts somewhere. The beginning of the universe may represent the emergence of the framework itself. Trying to describe it using ordinary language is like trying to explain the appearance of a canvas by referring to a painting already drawn upon it. One useful analogy is the beginning of a story. When reading a novel, every chapter follows from previous chapters. Characters make decisions based on earlier events. Causes lead to consequences. Yet the first page occupies a unique position. It introduces the story itself. Asking what happened in the chapter before the first page only makes sense if there actually was an earlier chapter. If the story begins there, then the question must be approached differently. The emergence of the universe may occupy a similar position in reality. It may not simply be another event within a longer sequence. it may represent the point at which the sequence itself became possible. This possibility has led scientists to explore a variety of ideas about the earliest stages of cosmic history. Some theories suggest that quantum fluctuations played a role in the birth of the universe. Others propose that our cosmos emerged from a deeper quantum state unlike anything found in ordinary experience. Certain models describe a transition from an earlier phase of reality, while others suggest that the universe could have arisen through processes that do not resemble conventional events at all. Although these ideas differ in important ways, they share a common challenge. They attempt to describe conditions where our familiar concepts begin to lose their meaning. At sufficiently early stages, distinctions between space and time may blur. The ordinary rules governing causality may no longer apply. Reality enters a domain where current theories become incomplete and new frameworks are required. What makes this moment so fascinating is that it stands at the edge of both knowledge and mystery. We possess powerful evidence that the universe evolved from an extremely hot and dense state. We can observe the remnants of that early era in the cosmic microwave background, a faint glow that fills the universe and serves as a record of ancient conditions. We can measure the expansion of space and reconstruct much of cosmic history. Yet the ultimate origin remains hidden behind a veil that modern science has not fully lifted. This hidden frontier reminds us that understanding the universe is not simply a matter of collecting more data. Some questions require us to rethink the concepts we use to describe reality. The beginning of the universe may not resemble any beginning we have ever experienced. It may represent a transition from a deeper level of existence where space, time, matter, and energy had not yet taken the forms we recognize today. The deeper we investigate this possibility, the more remarkable the mystery becomes. The universe appears to emerge from a region where ordinary explanations become uncertain and where the language of everyday experience begins to fail. What existed there remains one of the greatest unanswered questions in science. Yet an even more surprising possibility lies ahead. The first event in cosmic history may not have required a previous event at all. The very idea that every beginning must be caused by an earlier beginning may belong only to the universe that emerged afterward, and that realization leads directly to one of the most profound questions in cosmology. What if the first event did not have a prior event waiting behind it? The strongest assumption in human thinking is the belief that every event must be caused by something that came before it. This idea seems so obvious that most people rarely question it. Every experience in daily life appears to confirm it. A tree grows because a seed was planted. A building exists because someone constructed it. A wave forms because wind moves across the surface of the ocean. Everywhere we look, causes appear before effects, creating an endless chain stretching backward through time. Because this pattern is so familiar, many people naturally assume it must apply to the universe itself. If the universe began, then something must have caused that beginning. If there was a first event, then there must have been an earlier event that produced it. The logic feels unavoidable. Yet when scientists and philosophers examine the origin of reality, they encounter a surprising possibility. What if the first event did not have a previous event? What if the demand for an earlier cause only makes sense within the universe and not at its origin? This idea initially feels uncomfortable because it conflicts with ordinary intuition. Human beings are accustomed to thinking in sequences. We imagine one thing happening after another. We picture chains of events extending into the past. When confronted with a beginning, our minds instinctively search for something that happened before it. The difficulty is that this habit may depend entirely upon the existence of time. Every cause we have ever observed occurs within time. The first event happens, then another follows. The relationship between cause and effect depends upon temporal order. Without time, the distinction between before and after becomes impossible to define. This creates a profound challenge when discussing the beginning of the universe. According to modern cosmology, time itself may have emerged together with the universe. If this is true, then the first event was not simply the earliest event inside an already existing timeline. It may have been the event through which the timeline itself came into existence. A useful analogy comes from the beginning of a road. Imagine standing at the first point of a road and asking what part of the road lies farther behind it. The question seems reasonable until you realize that the road begins there. There is no earlier section within the road itself. Asking for a previous stretch of pavement assumes the road extends beyond its actual starting point. Some physicists suggest that asking what happened before the first event may involve a similar mistake. The question assumes that time extends beyond the beginning of the universe in the same way a road extends beyond a point on a map. If time itself began with the universe, then there may be no earlier moment available for a prior cause to occupy. This idea becomes even more interesting when we consider quantum physics. In the everyday world, events often appear deterministic. Causes produce predictable effects. If you know enough about a situation, you can usually explain why something happened. The quantum world behaves differently. Certain quantum events occur without obvious prior causes in the classical sense. For example, a radioactive atom may decay at a particular moment, yet modern physics cannot identify a specific earlier event, forcing that exact decay to occur. The process follows statistical laws, but the individual event does not possess a clear deterministic trigger. This does not mean quantum events happen without rules. They occur within a framework governed by probabilities and physical laws, yet they challenge the assumption that every event requires a conventional prior cause. Some researchers have wondered whether the origin of the universe might involve a similar principle. Emerging because an earlier event forced it to happen, the universe could arise through a process rooted in deeper physical principles where ordinary causality does not apply. Several cosmological models explore variations of this possibility. Some propose that the universe emerged from a quantum state that existed before conventional spacetime formed. Others suggest that the earliest moment should be understood as a transition rather than an event caused by something earlier. In these descriptions, the universe does not require a previous event in the way everyday objects require previous causes. The challenge is that human intuition evolved within a universe where time already exists. Every experience reinforces the idea that causes come before effects. As a result, imagining a reality where that framework breaks down is extraordinarily difficult. Consider a fish that has lived its entire existence underwater. Every experience confirms that water surrounds everything. Asking the fish to imagine existence outside water would be challenging because its entire understanding of reality depends upon that environment. Human beings may face a similar limitation when thinking about causality. We have never experienced existence outside time. Every memory, decision, and observation occurs within a temporal framework. Asking us to imagine a condition where time itself has not yet emerged may be just as difficult as asking the fish to imagine dry land. This possibility has led some philosophers to argue that the first cause may not be a cause at all in the ordinary sense. The origin of the universe may belong to a category of reality fundamentally different from the events we observe today. It may not be something that happened after another thing happened. It may represent a deeper transition from which both time and causality emerge together. What makes this idea so powerful is that it shifts the discussion away from an endless search for earlier events. Instead of asking what happened before the beginning, we begin asking what kind of reality could generate a beginning without requiring a prior event. The question changes from what caused the first cause to what made causality possible in the first place. This is a subtle but profound shift. It suggests that the first event may occupy a unique position in reality. Every event afterward participates in chains of cause and effect. The first event may stand outside that framework because it is the point at which the framework itself emerged. Of course, this does not eliminate the mystery. It makes the mystery even deeper. If the first event did not require a previous event, then we are forced to confront a reality where some of our most familiar assumptions no longer apply. The universe becomes more than a sequence of causes stretching backward through time. It becomes the birthplace of the very concepts we use to understand sequences at all. And this realization leads directly to an even more astonishing possibility. Perhaps the first event did not simply occur without a previous event. Perhaps cause and effect themselves were born together during the earliest moments of cosmic history, emerging as part of the same process that gave rise to space, time, matter, and the universe itself. The deepest assumptions hidden within almost every human thought is the belief that cause and effect have always existed. We rely on this idea so completely that it becomes nearly invisible. Every day we watch causes produce effects. We flip a switch and a light turns on. We push an object and it begins to move. We plant a seed and eventually a plant grows from the soil. The world appears to operate through an endless network of causes leading to effects, and effects becoming causes for other events. Because this pattern is so familiar, most people naturally assume it applies to the entire history of reality. If something exists, there must be a reason it exists. If an event occurred, something must have caused it. If the universe began, there must have been a prior cause responsible for that beginning. Yet when scientists and philosophers examine the earliest moments of cosmic history, they encounter a remarkable possibility. What if cause and effect themselves had a beginning? What if causality is not an eternal feature of reality, but something that emerged together with the universe? At first, this idea feels difficult to grasp because causality appears so fundamental. It seems less like a law and more like a basic requirement of existence. Without cause and effect, how could anything happen at all? The challenge is that our understanding of causality comes entirely from observing events within the universe. Every example of cause and effect we have ever experienced takes place inside space and time. Causes occur first, effects occur afterward. The relationship depends on the existence of a timeline connecting one event to another. This detail becomes extremely important when discussing the origin of the cosmos. If time itself emerged during the earliest stages of the universe, then the framework required for ordinary causality may not have existed beforehand. Cause and effect require temporal order. One thing must happen before another. If there is no meaningful concept of before and after, the traditional structure of causality becomes difficult to define. A useful analogy comes from the rules of a game. Imagine watching a chess match. Every move follows specific rules. A bishop moves diagonally, a rook moves in straight lines. The game makes sense because those rules exist. Now imagine asking what chess move occurred before the rules of chess were created. The question immediately becomes confusing because the rules are what make moves possible in the first place. Some physicists believe causality may occupy a similar position in reality. Instead of existing before the universe, causality may be one of the rules that emerged with the universe itself. It may be part of the structure that appeared when space-time, matter, and energy first came into existence. This possibility changes the way we think about origins. Instead of searching for a cause that existed before everything else, we begin considering the possibility that the very distinction between cause and effect arose during the birth of reality. The idea becomes even more intriguing when we examine certain aspects of modern physics. Quantum mechanics has revealed that reality behaves very differently at extremely small scales than it does in everyday life. Particles can exist in states that challenge ordinary intuition. Events can occur according to probabilities rather than strict deterministic sequences. The deeper scientists investigate the quantum world, the more they discover that some familiar concepts become less straightforward than previously assumed. Although quantum mechanics does not eliminate causality, it demonstrates that the universe is capable of operating in ways far more subtle than our everyday experience suggests. This has encouraged some researchers to explore whether the earliest universe may have existed in a condition where conventional causality had not yet fully emerged. In such a state, reality would not resemble the ordered sequence of events we observe today. There would be no established timeline stretching into the past. There would be no familiar chain linking causes to effects. Instead, the processes giving rise to space-time itself would also give rise to the framework within which causality becomes meaningful. Imagine constructing a building. The walls, doors, and windows all depend upon the foundation. Yet the foundation itself is not built upon those features. It occupies a different level within the structure. Some cosmological theories suggest that causality may be similar. The universe we observe depends upon causal relationships. The deeper processes responsible for generating the universe may not. This perspective helps explain why questions about the first cause become so difficult. We naturally search for an earlier cause because every event we know follows that pattern. Yet if causality emerged together with the universe, then asking what caused the first cause may be like asking what supported the foundation before the foundation existed. The question assumes a framework that may not yet have been present. Another way to understand this idea is to imagine tracing a river back to its source. As long as the river exists, every section is connected to an earlier section upstream. Eventually, however, you arrive at the spring where the river begins. Beyond that point, there is no earlier part of the river. The conditions that create the river exist, but the river itself does not extend farther back. Some physicists propose that causality may possess a similar origin. Within the universe, causes and effects form an enormous network stretching across cosmic history. Near the beginning, that network may terminate because the conditions required for causality are only just coming into existence. This possibility has profound implications. It suggests that the origin of reality may not be an event occurring within a pre-existing system of causes. Instead, it may be the emergence of the system itself. Space emerges, time emerges, matter emerges, energy emerges, and alongside them, the framework of cause and effect emerges as well. If this picture is correct, then the universe did not merely appear within an already existing reality governed by causal laws. The causal laws themselves became part of the universe's earliest structure. This realization transforms one of the oldest questions ever asked. For centuries, people have wondered what caused the beginning of everything. Yet the deeper we investigate the origin of reality, the more it appears that the beginning may not be something that can be understood through ordinary chains of causes and effects. Instead, the beginning may represent the moment when those chains first became possible. The mystery does not disappear. It becomes even more profound. Rather than asking what event happened before the first event, we begin asking what kind of reality could give rise to a universe where causality exists at all. We move beyond the search for an earlier cause and toward a deeper question about the foundations from which both time and causation emerged. And that question leads directly to another astonishing frontier. If cause and effect were created together with the universe, then what kind of reality, if any, existed before space, time, matter, and the laws of physics themselves came into being? Few ideas are more difficult for the human mind to grasp than the possibility of a reality existing before space, time, and matter. Every experience we have ever had takes place within a universe filled with locations, durations, objects, and events. We live inside space, we move through time, we interact with matter. These concepts are so fundamental to our daily lives that imagining their absence feels almost impossible. Yet when cosmologists investigate the deepest questions about the origin of the universe, they encounter a remarkable possibility. The universe may not have emerged from an empty region of space. It may not have emerged from a previous moment in time. Instead, space and time themselves may have come into existence during the birth of the cosmos. If that is true, then one of the most profound questions ever asked immediately follows. What existed before them? The challenge begins with the word before. In ordinary language, before refers to an earlier moment in time. Yesterday came before today. Childhood came before adulthood. One event happened before another. Every use of the word assumes that time already exists. But if time itself emerged with the universe, then asking what happened before time may involve using language in a way that no longer makes sense. It is similar to asking what lies farther north than the North Pole. The question appears reasonable at first, but eventually we reach a boundary where the concept itself stops functioning in the way we expect. This realization has led many physicists to approach the mystery from a different direction. Instead of asking what happened before the universe, they ask what kind of reality could give rise to a universe. The distinction is subtle but extremely important. The goal is no longer to find an earlier event. The goal is to understand whether a deeper level of existence could exist beyond the familiar framework of space and time. Imagine standing inside a vast building your entire life. Every room, hallway, and staircase belongs to the structure around you. If someone asked what exists outside the building, you might struggle to answer because every experience you have ever had occurs within its walls. Human beings may face a similar limitation. Everything we know exists within space-time. Every observation, experiment, and measurement takes place inside the framework of the universe. Asking what exists beyond that framework forces us into territory where ordinary intuition becomes unreliable. Some of the most intriguing ideas in modern physics suggest that space-time may not be fundamental. Instead of being the deepest layer of reality, space and time could emerge from something more basic. A useful comparison comes from waves on the surface of an ocean. To someone observing only the waves, the surface appears to be the entire story. Waves rise and fall. They move across the water. They interact with one another. Yet the waves are not fundamental. They emerge from the deeper existence of the ocean itself. Without the ocean, there would be no waves. Some physicists believe space-time may be similar. The universe we experience could be like the waves, while a deeper reality beneath it remains hidden from direct observation. This possibility has inspired a wide range of theoretical models. Some suggest that reality is fundamentally quantum in nature. According to these ideas, the universe emerged from a quantum state that did not resemble ordinary space and time. Instead of locations and distances, this deeper level may have consisted of probabilities, relationships, or quantum structures unlike anything encountered in everyday life. Others propose that information occupies the deepest layer of reality. In these models, space, time, matter, and energy emerge from more fundamental informational patterns. Just as a complex image can emerge from arrangements of digital information, the physical universe could emerge from a deeper informational foundation. There are also theories suggesting that space-time itself is an emergent phenomenon arising from networks of quantum connections. In such descriptions, the familiar geometry of the universe is not the starting point. It is the result of processes occurring at a more fundamental level. Although these ideas differ significantly, they share a common theme. The reality underlying the universe may not resemble the universe. This is one reason the mystery is so difficult to visualize. Human imagination depends heavily on familiar concepts. When people think about existence, they instinctively picture places, objects, and events. Yet a realm preceding space-time may contain none of these features in recognizable form. There may be no distances. There may be no directions. There may be no sequence of moments. There may be no matter. Reality at that level could operate according to principles completely unlike those governing the observable cosmos. A useful analogy comes from mathematics. A mathematical equation can describe an entire world of relationships without containing physical objects. The relationships exist even though they are not located anywhere in space. Some physicists wonder whether the deepest level of reality may possess a similar character, existing independently of the space-time structures that later emerge. This possibility becomes even more fascinating when we consider the origin of the universe itself. The Big Bang is often described as the beginning of everything, but modern cosmology is more cautious. The Big Bang marks the earliest stage of cosmic history that our current theories can meaningfully describe. What lies beyond that boundary remains uncertain. Some researchers suspect there may be a deeper reality beneath it. Others argue that the question itself may ultimately prove meaningless, because space-time and existence began together. The truth is that science has not yet reached a definitive answer. The mystery remains open. Yet the search continues because understanding the origin of the universe may require understanding what lies beyond the universe. The most profound aspect of this mystery is that it challenges the very foundations of human thought. Nearly every concept we use to understand reality depends upon space and time. If there truly exists a realm beyond them, then describing it may require entirely new ways of thinking. The deeper scientists investigate the origin of existence, the more they encounter signs that reality may extend beyond the categories we currently understand. The universe may not be the deepest layer. It may be the visible expression of something more fundamental, hidden beneath the surface of space-time itself. And this realization naturally leads to another extraordinary question. If a mysterious realm exists beyond space, time, and matter, does reality require a true beginning at all? Or is it possible that existence has no ultimate starting point, and that the search for a first cause is leading us toward a completely different understanding of what it means for something to exist? The oldest and most profound question ever asked is whether existence itself requires a beginning. At first, the answer seems obvious. Nearly everything we encounter in everyday life has a starting point. A book begins with its first page. A river begins at its source. A building begins with construction. Human experience constantly teaches us that things come into existence, develop over time, and eventually change into something else. Because this pattern is so familiar, it feels natural to assume that the universe must follow the same rule. Yet when we apply this intuition to existence as a whole, the question becomes far more complicated. The difficulty arises because we are no longer asking about the beginning of a particular object or event. We are asking about the beginning of reality itself. This distinction changes everything. When we explain the origin of a tree, we can point to a seed. When we explain the origin of a star, we can point to a cloud of gas. In each case, the explanation refers to something that already exists. The cause is part of a larger reality. The question of existence is different because it asks about the larger reality itself. If everything began, what was present before that beginning? If reality emerged, what allowed it to emerge? If existence had a starting point, what explains the existence of that starting point? This is why the search for an ultimate beginning often leads to deeper questions rather than final answers. Imagine standing in front of a long chain hanging from the ceiling. You trace the chain upward, link by link, trying to find the first one. Eventually, you reach the point where the chain is attached. The mystery of the chain's support is resolved because something outside the chain holds it in place. Now imagine a different situation. Imagine a chain extending upward into darkness with no visible support. The farther you look, the more links appear. The question becomes whether the chain must eventually be attached to something, or whether it could continue indefinitely. The debate about existence often resembles this second situation. Some thinkers argue that reality requires a fundamental starting point. According to this view, an endless chain of explanations is not enough. If every event depends upon an earlier event, then the entire sequence still requires a foundation. There must be something that does not depend upon anything else. Something that serves as the ultimate source from which everything emerges. This idea appears in many philosophical traditions and remains influential today. The reasoning is straightforward. If every explanation depends upon another explanation, then nothing is ever truly explained. The chain continues forever without reaching a final foundation. To avoid this problem, reality must ultimately rest upon something fundamental. Others take a very different position. They argue that the demand for an ultimate starting point may be unnecessary. According to this perspective, reality does not need a first moment, any more than a circle needs a first point. Certain structures can exist without possessing an absolute beginning. The universe may be part of a larger process that extends beyond the limits of our current understanding. This possibility becomes especially interesting when viewed through the lens of modern cosmology. Several theoretical models suggest that the universe may not have emerged from an absolute beginning. Some propose cyclic cosmologies, in which periods of expansion and contraction repeat over immense spans of time. Others describe bouncing universes, where a previous cosmic phase gives rise to the next. Still others explore quantum frameworks, in which the distinction between beginning and continuation becomes blurred. These models remain speculative, but they demonstrate an important point. Modern physics does not automatically require the universe to have a single, clearly defined starting moment. The issue becomes even more intriguing when we consider time itself. Much of the debate depends on how we think about temporal existence. In everyday experience, beginnings occur within time. A race begins at a specific moment. A conversation begins at a specific moment. Every starting point exists against the background of an already flowing timeline. The origin of the universe may not fit this pattern. If time emerged together with the universe, then the beginning of reality may not have occurred within a larger temporal framework. In that case, asking whether existence had a beginning becomes more complicated, because the concept of beginning itself depends upon time. This realization forces us to question assumptions that normally seem unquestionable. Existence requires a starting point. It does not. The question itself depends upon concepts that only make sense within the universe rather than beyond it. A useful analogy comes from a map. Imagine drawing a map of a country and then asking where the map exists within the map. The question cannot be answered because the map describes the country, not the paper on which the map is printed. The framework being used is not capable of containing its own foundation. Some philosophers suggest that our questions about existence may face a similar limitation. We use concepts developed inside reality to ask about the origin of reality itself. Those concepts may be incomplete when applied to the deepest levels of existence. What makes this mystery so fascinating is that both possibilities remain difficult to dismiss. If existence has an ultimate starting point, then we must explain how such a beginning occurred and why it exists. If existence has no ultimate starting point, then we must understand how reality can exist without one. Either path leads to profound questions that challenge ordinary intuition. The deeper we investigate the issue, the more we realize that existence may not resemble the objects and events we encounter in everyday life. It may possess properties unlike anything familiar. The universe may be part of a larger structure. Reality may be self-contained in ways we do not yet understand. Or there may indeed be a fundamental source from which everything ultimately emerges. At present, science does not possess a definitive answer. The mystery remains open, yet the search itself has transformed our understanding of the cosmos. What began as a question about the beginning of the universe has evolved into a question about the nature of existence itself. It forces us to confront the possibility that reality is far stranger than our ordinary assumptions suggest. And that realization naturally leads to another question. If existence does require some kind of foundation, what exactly triggered the emergence of reality? What process, principle, or deeper level of existence could stand behind the appearance of the universe and give rise to everything that followed? Throughout human history, people have searched for explanations. Every civilization, every philosophy, and every scientific tradition has attempted to understand why things exist and how they came to be. Most of the questions we ask concern particular parts of reality. We ask why stars shine, how galaxies form, why gravity exists, or how life emerged on Earth. These questions are difficult, but they all share something in common. They assume that reality already exists and focus on understanding specific features within it. The search for what triggered reality itself is different. It does not ask why something inside the universe happened. It asks why there is a universe at all. It seeks the origin not of a particular object or event, but of existence itself. This makes it one of the most challenging questions ever considered because it forces us beyond the boundaries of ordinary explanation. In everyday life, explanations usually involve causes that already exist. A house is built by builders, a river is fed by rainfall, a planet forms from clouds of gas and dust. Each explanation works by connecting one thing to another thing that already belongs to reality. The origin of reality itself does not allow such an approach so easily. If we ask what caused the universe, the answer cannot simply be another ordinary event inside the universe, because the universe is the framework within which all ordinary events occur. The question pushes us toward the deepest foundations of existence. This is why the search for what triggered reality itself has fascinated both scientists and philosophers. It stands at the point where cosmology, physics, logic, and metaphysics begin to overlap. No single field possesses a complete answer. Instead, each provides part of a larger picture. Modern cosmology has revealed a remarkable amount about the universe's history. Scientists can trace cosmic evolution back nearly 14 billion years. They can describe the formation of galaxies, stars, planets, and the large-scale structure of the cosmos. Observations of the cosmic microwave background provide a glimpse of the universe when it was only a fraction of its current age. Yet even with these achievements, the ultimate origin remains hidden. The reason is that science excels at describing how one state evolves into another. It explains transitions, it explains processes, it explains relationships between events. The question of why reality exists at all may require something deeper than a description of processes occurring within reality. Imagine reading a detailed history of a kingdom. The book explains every ruler, every war, every discovery, and every transformation. By the final page, you understand how the kingdom changed across centuries. Yet one question remains unanswered. Why does the kingdom exist in the first place? History explains development. It does not explain existence. Cosmology explains much of the universe's development. The deeper question concerns existence itself. Several possibilities have been proposed. One possibility is that reality emerged from a quantum process. In quantum physics, empty space is not truly empty. Even what appears to be a vacuum contains fluctuations and possibilities governed by quantum laws. Some physicists have suggested that universes may arise from quantum conditions in ways that do not require a conventional cause. This idea is often misunderstood. It does not mean the universe came from absolute nothingness. A quantum vacuum still possesses structure, laws, and properties. The deeper question then becomes why those laws and properties exist. The mystery simply moves to another level. Another possibility is that reality emerged from a more fundamental framework beyond space-time. In some theoretical models, space and time are not the deepest ingredients of existence. Instead, they emerge from deeper quantum structures, informational networks, or mathematical relationships. The universe we experience would then be the visible expression of a more fundamental reality hidden beneath it. This approach shifts the question from what caused the universe to what gives rise to the deeper framework from which universes emerge. Again, the mystery remains. Some thinkers propose that existence may be necessary rather than caused. According to this view, reality does not require an external trigger, because its existence is fundamental. Just as certain mathematical truths do not need causes, perhaps reality itself belongs to a category that simply exists by necessity. This idea is difficult to evaluate because human experience is filled with contingent things, objects, and events that could have been different. The concept of necessary existence feels unfamiliar, because we rarely encounter it directly, yet it remains one of the most influential approaches to the problem of origins. There is also the possibility that our current understanding is incomplete in ways we cannot yet imagine. History repeatedly demonstrates that reality is often stranger than expected. Ancient observers could not have predicted quantum mechanics. 19th century scientists could not have anticipated curved spacetime. Concepts that once seemed impossible eventually became central to our understanding of nature. The ultimate origin of reality may involve principles that remain entirely beyond current theories. This possibility encourages humility. Whenever we ask what triggered reality itself, we are attempting to investigate the deepest foundation of everything we know. The challenge is extraordinary because every tool we use for investigation belongs to the reality we are trying to explain. It is like a character in a novel attempting to understand the existence of the book. The character can study the story, identify patterns, and analyze events, but the source of the narrative exists at a different level than the narrative itself. Humanity may face a similar situation when confronting the origin of existence. Yet despite these difficulties, the search continues. Scientists build new theories. Physicists develop deeper models of space-time and quantum gravity. Philosophers refine arguments about causation and necessity. Each approach contributes another piece to the puzzle. What makes this search so compelling is that it touches every aspect of reality. The answer, if it is ever found, would not simply explain the beginning of the universe. It would explain why there is a universe capable of containing stars, galaxies, life, consciousness, and questions about existence. The deeper we investigate, the more we realize that the mystery is not merely about a distant moment in the past. It concerns the foundations supporting every moment, including the present one. Reality is not only something that began, it is something that continues to exist right now, and understanding why remains one of the greatest challenges ever undertaken. This realization leads naturally to the final question of our journey. If the search for the first cause reveals deeper and deeper layers beneath ordinary explanations, then what does that search ultimately tell us about the nature of the universe itself? What does the mystery of the first cause reveal about the deepest structure of reality and our place within it? After exploring questions about beginnings, causality, time, existence, and the origin of reality, it is natural to expect that the search for the first cause should eventually lead to a final answer. Human beings are accustomed to solving problems by finding explanations. We identify a mystery, gather information, and gradually move closer to understanding. In many areas of science, this approach has produced extraordinary success. We have learned how stars generate energy, how galaxies evolve across billions of years, how life adapts through evolution, and how matter is built from fundamental particles. Yet the mystery of the first cause occupies a different category. The deeper we investigate it, the more we discover that it is not merely a question about the beginning of the universe. It is a question that exposes the deepest assumptions we hold about reality itself. It forces us to examine ideas that normally remain hidden beneath everyday experience. Concepts such as time, causality, existence, and explanation appear straightforward when applied to ordinary events. At the level of the first cause, however, they become far more complex. This is one reason the search for the first cause remains so important. Even before an ultimate answer is found, the journey itself reveals something profound about the universe. It shows that reality may be far deeper and more subtle than our ordinary intuition suggests. Consider how dramatically our understanding of the cosmos has changed over time. There was a period when people believed Earth occupied the center of creation. Later discoveries revealed that Earth is one planet orbiting an ordinary star. That star belongs to a galaxy containing hundreds of billions of other stars. Our galaxy is only one among countless galaxies spread across an immense observable universe. Each step outward expanded our perspective and revealed that reality was larger than previously imagined. The search for the first cause continues this pattern, but in a different direction. Expanding outward through space, it moves inward toward the foundations of existence. The deeper we travel, the more we encounter layers of reality that challenge familiar assumptions. We discover that space may not be fundamental. Time may not be fundamental. Even causality may depend upon conditions that emerge during the earliest stages of cosmic history. What begins as a search for an origin gradually becomes a search for the architecture underlying reality itself. The most important lesson emerging from this search is that the universe appears to possess an extraordinary degree of order. Physical laws remain consistent across enormous distances. Mathematical relationships describe phenomena ranging from subatomic particles to entire galaxies. The cosmos is not a random collection of disconnected events. It exhibits structure, coherence, and patterns that can be studied and understood. This raises an intriguing question. Why is reality intelligible? Why does the universe possess laws that can be expressed mathematically? Why does nature display regularities that allow scientific investigation to succeed? The mystery of the first cause brings these questions into focus because it directs attention toward the foundations supporting the entire cosmic structure. Imagine entering a vast library filled with millions of books. At first, you become interested in individual stories. Eventually, however, you begin wondering about the language connecting them all. The language is not merely one book among many. It is the framework that makes every book possible. The first cause occupies a similar position in relation to existence. It concerns the underlying framework from which all events, objects, and processes emerge. Another remarkable insight involves the relationship between simplicity and complexity. The universe today contains extraordinary complexity. Galaxies contain stars. Stars contain planets. Some planets support life. Life develops consciousness capable of reflecting upon the cosmos itself. Yet modern cosmology suggests that all of this complexity emerged from an earlier state that was far simpler. This transformation from simplicity to complexity is one of the most fascinating features of reality. The first cause mystery asks how such a process became possible. How did a universe capable of producing conscious observers emerge from the earliest conditions of existence? How did the potential for everything we see today become embedded within the foundations of reality? These questions reveal that the first cause is not merely about the distant past, it is also about the present. The same reality that gave rise to the universe continues to sustain its existence. Every star, every galaxy, every living organism, and every thought occurs within a cosmos whose ultimate foundation remains mysterious. The search also reveals something important about the limits of knowledge. Throughout history, scientific progress has often involved replacing mystery with understanding. Yet the first cause demonstrates that some questions become deeper as knowledge increases. Every discovery opens new possibilities while revealing additional layers of complexity. When astronomers learned that the universe was expanding, they gained insight into cosmic history. At the same time, new questions emerged about the origin of that expansion. When physicists developed quantum theory, they explained many previously mysterious phenomena. Yet quantum mechanics introduced entirely new puzzles concerning probability, measurement, and reality itself. The first cause sits at the convergence of these expanding horizons. Rather than shrinking as knowledge grows, the mystery evolves into increasingly profound forms. This does not mean the search is futile. On the contrary, it highlights one of the greatest strengths of scientific inquiry. The goal of science is not merely to accumulate answers, it is to deepen understanding. Sometimes understanding reveals that reality is more astonishing than originally imagined. The first cause may ultimately teach us that existence is not something that can be reduced to a simple chain of events. The universe may emerge from principles more fundamental than space and time. Reality may possess layers beyond current observation. The concepts we use to describe ordinary experience may represent only a small part of a much larger picture. Some physicists suspect that future breakthroughs in quantum gravity will provide new insight into these questions. Others believe that understanding the origin of reality will require entirely new conceptual frameworks. There are even those who argue that certain aspects of the mystery may remain permanently beyond human comprehension. At present, no consensus exists. What remains clear is that the first cause continues pointing toward the deepest frontier of knowledge. The most profound revelation is that the universe appears to be a reality capable of generating questions about itself. Out of cosmic evolution emerged conscious beings able to investigate their own origins. The atoms within our bodies were forged inside ancient stars. The laws governing our existence are the same laws shaping distant galaxies. The universe has produced minds capable of looking backward through cosmic history and asking why anything exists at all. This fact alone is extraordinary. The search for the first cause is therefore more than a scientific investigation. It is a reflection of humanity's unique relationship with the cosmos. We are not separate from the universe attempting to understand it. We are part of the universe seeking to understand itself. The deeper we explore the mystery, the more it reveals a reality that is interconnected, structured, and profoundly mysterious. The first cause may ultimately lie beyond the boundaries of current science, hidden within layers of existence not yet understood. Yet even without a final answer, the search reveals something essential. It reveals that the universe is not merely a collection of objects moving through space. It is a vast and unfolding mystery whose deepest foundations continue to invite exploration. Every galaxy, every particle, every moment in time points back toward a question that remains unanswered. Why is there something rather than nothing? Until that mystery is fully understood, the search for the first cause will remain one of the greatest intellectual journeys ever undertaken. It stands at the meeting point of science, philosophy, and human curiosity, reminding us that the deepest truths about reality may still be waiting beyond the horizon of our current understanding. The mystery of the first cause is not simply a question about the beginning of the universe, it is a question about why anything exists at all. Every discovery in science has carried us closer to the earliest moments of cosmic history, yet the ultimate origin remains hidden behind a horizon of unanswered questions. If time began with the universe, then the first cause may not be an event in the ordinary sense. It may belong to a deeper level of reality where our familiar ideas of before, after, cause, and effect no longer apply. Somewhere beyond the edge of our current understanding lies the answer to why existence emerged from the unknown. And until that mystery is revealed, the first cause will remain one of the most profound and fascinating questions ever asked by the human mind.